All right, here's a quick visual for how we are looking at variability in ANOVAs. I tried to move the board closer so it's easier to see. Let's imagine this is our population of students that we're working with, this big blue here. We have a mean of this whole group, which a lot of times in ANOVA you'll see referred to as the grand mean or the total mean. All right, so this is our group of students. Let's say that these are their stress scores that we're looking at. And let's say that when we plot these out, our education students are kind of here, or sorry, orange was math. Our math students are kind of here. Our business students are kind of here. And our education students are kind of like here, okay? So this would be a situation where there is a null hypothesis. We have these three groups, and even though the means of the groups might be a little bit different than the grand mean, like let's say our education mean is over here, our math mean, this orange, is over here. I think that looks about even. I'm trying to do this at a weird angle so y'all can see. And our business mean is right here, right about the average. Okay. Remember, the null hypothesis would be saying that each group has variability based on chance, based on external factors, based on things we're not measuring. But then apart that all those factors are acting the same way. They all have those same external factors, but at the end of the day, they're all pretty similar. Okay. This is the null hypothesis in an ANOVA, that there's no significant difference between math, education, and business. Now, the way we're going to measure this is using between groups and within groups. So let me get a couple of different colors to mark this with. All right, I'll try using green and a darker purple. Hopefully these show up. So what we mean when we're talking about within group variability is we're interested in variability the way we've been talking about it so far this semester. Within each individual sample, how much do the individual observations differ from the mean, right? So over here, let's use orange because we're going to be talking about our math majors. So over here within our orange plot, we would have our orange scores spread out within our plot that we would be comparing to the mean of the orange ones, the mean of the math majors. We'd be looking at the variability, right, and comparing our individual scores. And we'd be doing the same thing for all of this, right? We would come over here and we would also do this for our education scores. We would take our individual scores throughout education, which we've marked in green, and we'd compare them back to the education mean. So this is our within groups variability. We're not comparing our groups at all. We're looking at in our individual groups that we have, how does each score differ from the mean? Between groups then is where we want to look at our group means and say, how much does our group mean differ from our overall mean? How much does the mean of X differ from the mean of all my participants? How much does the mean of X differ from all? We can also draw it up on top. And this is how I think your textbook visualizes it, is it plots the means of each group on top like this, and it looks at how different those are from your grand mean over here. Okay, so how different is this? Now, what we're going to get into with these calculations, this looks like a mess. What we're going to get into with these calculations is we're going to look at this in terms of a ratio. And we're going to say, if the null hypothesis is true, the amount of variability within a group, the amount of variability within these individual scores and the group means should be about a 1-to-1 ratio with the amount of variability that we see between our groups. We're expecting these to be pretty close together. That would be a null hypothesis, right? These are all very similar. And so the individual scores to the group mean is about at a 1-to-1 ratio with the variability between our groups as we look at the group mean to the overall mean. So I'll clear this out and I will do a visualization of what this looks like if the null hypothesis is rejected and we actually have a significant difference.